Hi, this is our first video of the notes that we're going to have for today, Monday, Monday, March 16th. We're going to learn how to graph sine and cosine functions. It says to graph a function quickly, we're on page 167. To graph function quickly, a graphing calculator can be used to enter the function and then observed the graph on a rectangular coordinate system. Because sine and cosine both represent functions, the same can be done by graphing y equals f of x equals sine x and y equals f of x equals cosine x. Here the independent variable x represents the angle measured in degrees or radians, and the dependent variable represents the y coordinate on the unit circle. Usually when we graph, we use radians for the mode when we're graphing on a graphing calculator or even on a grid. You can see how these are radians. This is 0, and then pi over 2, pi, 3 pi over 2, etc. So we're going to put in some values. For 0 on the unit circle, the point is 1, 0, so the sign is 0. We're going to graph y equals sine x. So 0, 0 is the first point. It's important to remember that sine always starts at the origin. And then for pi over 6, it's rad 3 over 2, 1/2. So 1/2 is the sine. So pi over 6 is 30 degrees. This is 90 degrees. So 30 degrees is at about a half. We're just approximating. Pi over 2 is 0, 1, so it's going to be 1, pi over 2, comma 1. So it goes up to 1. Nice smooth curve. 5 pi over 6 is right here, and it's at 1/2 again. 1/2, so 5 pi over 6, 1/2. And for pi, it's negative 1, 0, so we're at pi 0, right here, pi 0. Then we're going to do 7 pi over 6, which is right here, and it's 1/2. 7 pi over 6, 1/2. And then 3 pi over 2 is 0, negative 1, so it's negative 1. 0, negative 1. Nice smooth curve. We have 1/2 again. These are both negative 1/2. I should have said that. Negative 1/2. This is 11 pi over 6, negative 1/2, which is right here. And then we're back to 2 pi, or 0, which is 1, 0. So 0, 2 pi, comma 0. So that's the shape of a sine curve. One period of a sine curve goes up to 1, to 0, down to negative 1, back up to 0. When sine is between 0 and 2 pi, that's one period or one cycle. So this would continue on. We could keep going and going and going in both directions, the curve. So the domain is all real numbers. The domain is all real numbers. The range is between negative 1 and 1. So all our numbers y such that y is between negative 1 and 1. The sine function is an odd function, if you remember. It's odd. Cosine and secant are even. So the symmetry is just with respect to the, does anybody remember if it's odd what the symmetry it has is with respect to the origin? So if we graphed over here to continue our graph, you could see that this part would be reflected over, oops, you can't see it. If we graphed here and continued on, this part would be reflected here across the origin. This sine is periodic with a period of 2 pi. The x-intercepts are negative 2 pi, negative pi, 0, pi, 2 pi. All multiples of pi. See, everywhere that it touches the x-axis, 0, pi, 2 pi, it'll be 3 pi, 4 pi, 5 pi, all the multiples of pi. The y-intercept is the origin, 0, 0. The maximum value is 1, and it appears at all the pi over 2's. Pi over 2, 3 pi over 2, 9 pi over 2. Actually, is that right? Yeah, it is. Every 2 pi. So it's pi, 5 pi over 2, 9 pi over 2. You have to add 2 pi to it because the period is from maximum to maximum. From maximum to the next maximum is 2 pi. From the minimum to the minimum is 2 pi because it's a period away. So these are at 3 pi over 2, 7 pi over 2, 11 pi over 2. So that's the sine graph and the information about it. So we're going to graph this one with transformations. What is the basic function? The parent function is y equals sine x. What are the 3 transformations? Who can tell me what the negative does? Think about what the negative does. It reflects what? Reflects the x-axis. And then the 2 is a vertical stretch by a factor of 2. And then which way does a plus go? Translate left, pi over 4 units. And it calls it the basic function. We're going to call it the parent function because we've been doing that all year. Basic function, we're going to call it the parent function. So for our graph, we're going to graph y equals sine x. So we start at 0, 0, and it goes up, down, down, up. And I think they want us to keep doing it. Sorry about that. I think they want more than 1 period, and I went up to 2 instead of to 1. The amplitude, we're going to call it the amplitude, how high up the graph goes. It goes up to 1, not to 2. Okay, so it goes up to 1 and then to -1, and we're going to keep going in both directions. Usually we do 2 periods. So we didn't quite do 2 periods. But we will when we do the homework. We'll do 2 periods. We'll do 1 curve and then another curve. Then we graph it upside down. And we can multiply by -2 at the same time. So 0 times -2 is -0. And 1 times -2 is -2. So it goes like this. And then 0 times -2 is 0. And -2 times -2 is 2. So it goes up. And then back down. And this one goes up. and then back down. So that's the vertical stretch and graphing it upside down. And we move it left, pi over 4. Well, this is pi over 2, so we go halfway. So this is going to go halfway, and this is going to go halfway. Oh, but I was doing the original graph, so we have to do the blue graph halfway. The blue graph halfway, that's what whiteout is for. So this goes halfway, this goes halfway, that goes halfway. So we go like this and this. This goes halfway between 0, pi over 2 and pi. This goes halfway, that goes halfway, and that one goes halfway. So the red graph is the final graph. Then they want to do cosine x, and cosine x is very similar to sine x. It says 0, 0, but that was a mistake. It's 0, 1, because the point is 1, 0. So it's at 0, 1. The angle is 0 and the cosine is 1. And then at pi over 3, which is 60 degrees, is at 1/2. And at pi over 2, it's 0, 1, so it's a 0. Pi over 2, 0. So it's down here. So instead of starting at the origin, it starts up at 1. That's what makes it cosine. And then 2 pi over 3, 1/2. Negative 1/2. And pi is negative 1, 0. So we get negative 1, pi, negative 1. So it comes to negative 1 like this. 4 pi over 3 is still negative 1/2. 4 pi over 3, negative 1/2. 3 pi over 2 is 0, negative 1, so it's a 0. 3 pi over 2, 0, so it comes back to the 0, going through 1/2 at 4 pi over 3, negative 1/2. 5 pi over 3 is 1/2. 5 pi over 3, 1/2. And then back at 2 pi, which is 0, so it's 2 pi comma 0. Oh, comma 1. 2 pi comma 1, because it goes back up to 1. So that's what the basic cosine graph looks like. It's a nice smooth curve. So here are the properties of cosine. The domain is all real numbers. We could keep going. The range is y such that y is between negative 1 and 1. Cosine is an even function, so it's symmetric with respect to the y-axis. The cosine function is periodic, 2 pi. The x-intercepts are, well, if you look at your graph to see where it intersects the x-axis, it's pi over 2 and 3 over pi over 2, pi over 2, 3 pi over 2, 5 pi over 2, and if you went in the negative direction, negative pi over 2, negative 3 pi over 2, etc. The y-intercept is 1. 0, 1, or a pair. The maximum value is 1, and it occurs at negative 2 pi, 0, 2 pi. Every period it goes through 1.